I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we'll discuss derivative of exponential functions. In the playlist, you will find extensive knowledge and practice questions about this topic. We'll begin with very simple examples using the basic formula, which is if the function is given to you as e to the power of x, then its derivative is exactly e to the power of x. That really means that the y value of the function provides you the slope of tangent at that particular point. Do you appreciate that? So that's the beauty of this particular function. Now, if we have a function e to the power of g of x, then obviously you'll multiply the derivative e to the power of x by the derivative of the function g of x. So you have the other formula. Now, based on this basic formula, we have 6 questions for you. I'd like you to pause the video and begin answer these questions. Once you have done that, then in the coming or following videos, we can have slightly difficult questions. That is the next step. Questions like, you can see here, find all points at which the tangent to this curve is horizontal. Or the question here, find equation of tangent to the given graph. Or we are given an application question, we have to find the nth derivative. Or something like this, determine the nature of turning points for the given function, or something like this. Well, it is the same thing where we need to analyze the turning point for maximum or minimum. So I hope you are getting an idea of what we will be getting into as we talk about the derivatives of exponential functions in this playlist. Well, that is the basic. However, we are going to discuss examples related to all the formula of your interest on this particular topic. Now, this is specially designed for our IBSL math students. Here is the formula list which we are going to explore in the playlist. The first two, which is the basic derivative of e to the power of x, is e to the power of x itself. And if we have a function there, then you have to multiply it by the function. And after that, we'll consider examples b to the power of x or b to the power of g of x, ln x, log x, and so on. So, very extensive playlist for you. We'll have examples where we will find the basic derivatives. We'll discuss horizontal tangents, equation of tangent line, turning points, and also the higher derivatives. After that, in the next playlist, we'll take up examples related to application of exponential and logarithmic functions. I hope you find it interesting. In case you want to learn from me, feel free to send an email on the email address given. Most of my students really understand the topic and therefore they do extremely well, some of them being on top of their class just as Akshit.
After attending university. The winner of this year's Certificate of Achievement Schulich Leader Award is Akshit Kandivani.
Great. Our student Akshit gets highest marks and the most prestigious Schulich Leader Award. You can be there. Join our classes and excel. Now, let's begin with the solution of these questions one by one. I hope by now you must have got some of them through. They are kind of oral, right? Very, very simple. But no, when you are a beginner, it could be challenging. So do not underestimate these questions, correct? Let's begin with the very first one, which is y equals to 5 minus 3 e to the power of minus x by 2. Correct? So we need to find the derivative of this function, basically means dy dx. So when I do dy dx, you have to do dy dx of all these components, right? So d dx of 5 minus 3 e to the power of minus x by 2. Now this I'm only writing as a solution of the very first question. In the next solutions, I will do a shortcut method, right? So when you do that, you know that the derivative of 5 is basically 0. So that is what you get. And then you have minus 3 e to the power of x by 2. So the derivative of this should be what? Well, minus 3 e to the power of minus x by 2. That is applying the first rule, which is derivative of this function. However, you see a function on the top. So we need to multiply this by the derivative of the exponent, right? So I'm going to add here d dx of minus x by 2. So this is a critical step, and I've seen sometimes students miss this, and therefore they get a wrong answer. So if you have the derivative of minus x by 2, it is minus half, right? So this is minus half, and therefore, continuing with our derivative, what do we get? Well, we get minus 3 times minus half, which is the derivative of minus x by 2, e to the power of minus x by 2. So the function remains exactly same. Perfect. Now when you multiply these two negatives, you get your answer, which clearly is what? Which is minus and minus becomes plus, so you get 3 over 2 e to the power of minus x by 2. Is that clear to you? So definitely the answer for this, you could have written directly also, derivative of 5 being 0, minus times minus half is plus. So we get 3 over 2 e to the power of minus x by 2 as our solution. Is that clear to you? Now we are going to follow all these steps in the coming examples, but I'm not going to write these first 2 or 3 steps, right? We may just jump to the last 2. Okay, so here is a second example. We have y equals to e to the power of x minus e to the power of minus x over 4. Now it's a good idea to write this as 1 over 4 times, do you see that? E to the power of x minus e to the power of minus x. You see that? So if you write like this, it becomes simpler to see, well, it is just limits of, it is just derivatives of the two which need to be subtracted. So now from here, you can write down what dy dx is. Well, of course, the constant, it multiplies the derivatives of these two. Derivative of e to the power of x remains e to the power of x, and the derivative of minus e to the power of x will be what? Well, it will be minus e to the power of minus x times the derivative of the function, right? Which is minus 1. You see that? And therefore, we definitely get an answer which will be 1/4 of e to the power of x plus e to the power of minus x. You get the idea. So that is how the sign got changed to plus. Sometimes when you look at the answer, you find, oh, my sign is not correct. The reason is that you forgot to use the rule completely. The derivative of minus x should have been taken care of. Derivative of x was 1, so there was no need to write it. However, you always multiply by the derivative of this function, which is as an exponent in exponential functions. You get the idea. Okay, let's move on from here and get to the next question, which is now slightly difficult. So we have this question as y equals to what? So some of you will like to write this as y equals to. Instead of the square root thing in the denominator, some students prefer to write this as pi plus 2 e to the power of minus x to the power of minus half, right? No harm in doing that, right? Because most of the time, you're very familiar with this form. And now you can apply the power rule and then the chain rule. You get the idea. So here we are applying the power chain rule combination. Perfect. So what do you get? So you get dy dx for this particular question as, since it is minus half in the exponent, we'll write this as minus half. And the whole thing which is there inside it, which is pi plus 2 e to the power of minus x to the power of minus half minus 1, which is minus 3 by 2, right? Times the derivative of inside function. Do you see that? Derivative of this function. So let me write here, that is the chain rule, right? So d dx of pi plus 2 e to the power of minus x. Makes sense? And now you can write down the answer, which clearly is what? It is minus half times pi plus 2 e to the power of minus x to the power of minus 3 by 2. So that comes in the denominator. And the derivative of this function is what? Derivative of minus x is minus, and therefore we'll have this as minus 2 e to the power of minus x. Makes sense? Derivative of pi is 0. Perfect. So we get our answer, right? This negative, when multiplied with the other negative, and then we have half and 2 there, right? So we could cancel this 2, right? Do you see that? We could cancel this 2. And therefore, we get our answer. And this answer is, in the x numerator, we have e to the power of minus x, right? And then minus and minus makes it positive. And it is a good practice not to write your answers with negative exponents, right? So we have pi plus 2 e to the power of minus x to the power of 3 by 2. So that becomes the correct answer for this particular question. So a couple of things which you should notice here, and that is, this negative and negative becomes positive. We cancel the 2's, right? And then this exponent comes in the denominator, right? So that becomes your final answer. Is that clear to you? Perfect. So that is how you have to answer question number 3. I hope it is absolutely clear. If you have any doubts, you can always email me on this particular address. No problems, right? Okay, let's move on and take the fourth question here. The fourth question is, y equals to 1 plus 5 e to the power 3x over 2. Now, this is very similar to what we just did, right? So, I would like you to pause the video now and write down the answer for this particular question, right? That should not be difficult. So, let me write down the answer for you to check what you got, right? So, dy dx, you could also write y prime, perfect. And it is 2 times 1 plus 5 e to the power of 3x times the derivative of inside function, which is 5 times 3, right? So do you see I skipped one step this time? 5 times 3 e to the power of 3x. Makes sense, right? So that is the answer which you will get. And of course, you will multiply 15 by 2 and you will rewrite this as 30 times, you could write e to the power of 3x first if you want to, right? Times 1 plus 5 e to the power of 3x. Makes sense? So that becomes the answer for question number 4. Perfectly, it matches with what you got. Right. So we have now the next question where we're going to use the product rule. Now you can see we have y equals to square root of x times this. That means you have to use the product rule and also the rule which you learned just now for derivative of exponential functions with power as the argument. Okay, so the product rule basically is, let me rewrite for the benefit. If we have derivative of uv, for example, right? So u and v, right? Both. So if you want to find the derivative of this, in that case, what do we have? Derivative of u times v plus u times v derivative. Correct. So that is what it is. So we are going to apply this product rule and write down the solution for the next question. So we have y prime, which is same as dy dx. Derivative of square root of x is 1 over 2 square root x, perfect, times e to the power of 2x. And then you have to add this to square root of x times derivative of e to the power of 2x, which is e to the power of 2x and derivative of exponent, which is times 2. You get the idea. So we immediately have written our answer. So many times they will say do not simplify. You may leave it as such. But if you want to simplify, then you could take this as a common denominator, right? So if you could take this as common denominator, which is 2 square root of x, then what do you get? You get e to the power of 2x, right? And here you get plus. You have to multiply this by 2 and square root x. So it becomes 2 times 2, 4, right? X e to the power of 2 of x. You get the idea. So you may get this kind of an answer in the answer book sometimes. So that is how you get it. Many of those answer books might just take e to the power of 2x as common also and then further simplify. So that may be important. At times we may write e to the power of 2x, right, times within bracket 1 plus 4x, correct, divided by 2 square root of x. Now this is a very important form, correct? So it tells you a couple of things, and that is the derivative of this function is not defined at x equals to 0. Do you see that? So at x equals to 0, the derivative is not defined. This is one thing which you could get from this particular derivative, as the question could be combined with many things, right? You will also find that the numerator could be 0 for what value of x, which is minus 1 over 4, right? So we will extend this question, right? Extend. And that is question 1a is find points where y prime equals to 0. Y prime equals to 0 means horizontal, right? Tangent. Do you understand? So if the question could be find the points where the function has a horizontal tangent, right? That means a turning point, right? Remember that. So that could be this. And then question part B could be find a point where the derivative is not defined, right? So that is where it is not defined. Remember, the domain of this function is x greater than equal to 0. So x equals to 0 is in the domain of the function. However, at x equals to 0, the derivative is not defined. You can clearly see that's in the denominator. Makes sense, right? So you could do that. And this is actually an important function, as I could also extend this and ask you increasing and decreasing interval of this particular function. You get the idea. So it could be a very complicated question at times. But I hope you have understood the basics. How do we find the derivative? And in the coming videos, we will explore all these properties also. Perfect. Now let's move on and take the next example. I hope you understand and appreciate what we are trying to do here. We are not just trying to apply the simple formula here. We're trying to give you the information on how you should be seeing these simple derivatives in the coming questions, right? That could be your test problem. So in case you want to really learn from me and see how you can perform very well and get high marks in your test papers, in that case, you can contact me on this particular address. Make sense? Okay. So now we are almost at the end. So the last question here is dealing with the quotient rule. So we have y equals to e to the power of x plus 2 divided by e to the power of minus x plus 3. So just to give you the formula to begin with, if I have a function which is u over v, and if I want its derivative, then what should I do? Well, the denominator square derivative of the numerator times denominator minus numerator times denominator derivative. Simple formula, right? So we have just placed the formula like this. And now let's find the derivative of the given function. So y prime is equal to denominator square, which is e to the power of minus x plus 3 whole square, right? Now, the derivative of the numerator is e to the power of x, okay, times the denominator e to the power of minus x plus 3. You can open this, simplify, minus. So important, this is minus in between, right? Derivative of the denominator is actually minus this, right? So let me write like this, e to the power of x plus 2 as I've written the formula, and the derivative of this will be minus 1 times e to the power of minus x. Makes sense? So this minus and this minus cancels, and there is e to the power of minus x here. You could open the bracket, right? So the idea here is that you need to simplify this, okay? So we have minus x plus 3 whole square. You need to simplify all this. So you could actually multiply these things, correct? So when you multiply e to the power of minus x with this function, what do you get, right? What do you get? So you get just 1, right? And 3 e to the power of x. Perfect. And when you open this, you get plus here, correct? So we get 1 plus 3 e to the power of x. right? And then we have negative and negative, which gives you positive. You see that? Negative and negative gives you positive, and therefore this is positive. And now we multiply e to the power minus x with e to the power of x, which is also 1. And then with 2, you multiply e to the power of minus x. So we have plus 2 e to the power of minus x. You see how simple form it is? And 1 plus 1 is 2, and these two can be further combined. So I'd like you to now simplify further, right? And then write down your answer. Does it make sense to you? So with that, we have actually covered the solution of all these 6 questions. So we started with the basics, and we did, different kinds of questions here. And that gives you complete information of how do we solve equations where the exponential functions are involved, and this becomes our level 1. I will say this as level 1, the beginner's level for this particular topic. Correct. So these 6 sets of questions are your level 1. And if you really want to try something more, try these questions which I am sharing with you now. Their solutions will be shared in the coming videos which are there in this particular playlist. I hope that makes sense. Feel free to contact us on the email address given here, which is globalmathinstitute.com@gmail.com. Perfect. So, globalmathinstitute@gmail.com is the email address. Perfect. If you like and subscribe to my videos, that would be great. As usual, keep sharing your thoughts and comments. Thank you. All the best.